So when we do these types of questions, our question yesterday was how do we determine which vector to put this, like the object's motion or velocity at? And so you choose it based on exactly which direction they're going. And it sounds simple because it is, but we made it more complex, I think. So I'll go through a couple examples of how to know exactly where to put each velocity vector. So for this one, let's draw our river is as so. The distance is 200 meters wide. And it's flowing west. So I have a velocity of my current. I'm just going to put in my diagram just to kind of specify what I'm dealing with. V current is equal to 1.2 meters per second. Now, the swimmer is going to point herself north. So if the swimmer points herself north, so that's how we determine the vector direction for the object. If the object is pointing themselves to go that way, that's the velocity that we put, whichever direction that they are directing themselves or the object is being directed toward. So this is not tip to tail, this is just drawing out our diagram, and then we'll put in our triangle later. So this is our velocity of our swimmer going north. B swimmer is equal to 1.8 meters per second. So when we're trying to find, these are all called relative motion questions. So when it says her velocity relative to the ground, that means if somebody was watching the swimmer from the shoreline, what would it look like? Okay? So if we have the current flowing this way, west, and the swimmer starts to go the direction of north, which way are they going to get pushed? With the current, right? They're going to get pushed kind of northwest. So, what was I trying to say? So from the shore, they will be looking like they are moving down the river, right? So that's, when they say find the velocity relative to the ground, that's like what it would look like from the shore. So how we see that she appears to move. So you guys can all tell me, well, will it look like she appears to move northwest? But really her body is just going north. Like she is directing her body north, but she appears to be moving northwest because physically that's actually what's happening. Okay, so now let's draw our diagram. So remember, it's important for our vectors to be tip to tail, our north, south, and east and west. So here I'm going to draw my west end first. This velocity is 1.2 meters per second. Then I'm going to go the tail of my next vector and go up, and this is the velocity of my swimmer, is 1.8 meters per second. Because my swimmer is aiming themselves north, so that's why I put that velocity on that vector, because that's the direction that they are meaning to go. The direction that they get pushed, that we see, is this overall northwest vector. I also know another piece of information. I know the distance of my vertical vector. I know that this distance is 200 meters. So this is just setting up what I know, setting up my vector diagram, okay, vector diagrams. Now let's actually look and see what were we trying to find out. Her velocity relative to the ground. Okay, her velocity relative to the ground is this, the green arrow. This is the relative motion. We're trying to find out the v of that relative motion, what she appears to be moving at, relative to the shoreline. So, how do we find out the v of that line? Pythagorean's theorem, yeah. So we can go our a squared plus b squared is equal to c squared. So you can set, like, say this one is a, this is b, and this is c. So 1.8 squared plus 1.2 squared is equal to c squared. So then c is equal to 2.16 meters per second, which, if we think about it, the actual person is swimming 1.8 meters per second. This is faster. That seems obvious, right? Because the river is pushing the swimmer down with the current. So she's going to be moving across faster than what she could physically swim. Right? Like, you know that when you get in the river, and you move down, you're swimming kind of with the current downriver, you move faster, right? And so that's why this would make sense. It's a faster current. But we were asked to find velocity, so what do I need? I also need direction with this. So what I find is my angle of the vector, the overall relative vector there. Yes, so this is not my final answer. Yeah. Okay, so to find that information, I'm just going to pop down here. So you can use any side, so you can use tan, sine, or cos. I chose tan because that's what I started with as my opposite and my adjacent information. If you pick something else, it should get the same angle though. So theta is 56 degrees. So now, yes, as Ray said, we need to put our answer into sig digs. So our V arrow, our answer is 2.2 meters per second, 56 degrees north of west. Also, an acceptable answer, if you drew your vector diagram a little differently, you could, or if you just calculated it differently, could be 34 degrees west of north. Either one are correct. Okay, so next we were asked to also find the time it takes her to cross. So time, again, is the same no matter which side of the triangle you're on, because we're all dealing with the same event happening at the same time. So I'm going to use the information that I've given both the V and the D. So I'm going to take my vertical information and use that to find out my time. So all of my vertical information, my V is equal to 1.8 meters per second, and my D is equal to 200 meters. T will be D divided by V. So T is equal to 111.11 seconds. This needs to be to 2 sig digs. So 1.1 times 10 to the power of 2 seconds.
What if you put it in minutes?
Oh, that's fine too. Yeah.